So in this video, I'm going to talk about these solving Fourier problems of inscribed angles. And the question is, the circle is centered in point B. So point B is the center of our circle, and points points ACD lies on its circumference. If angle ABC, so ABC, this angle right over here, if that angle measures 70 degrees, so we can see that this angle is 70 degrees. What does the angle ADC measure? So what does the angle ADC, this angle, what does the angle measure? So we can think about a little bit. We can think about inscribed angles. Inscribed angles are formed with the two lines. But the end point should lie on the circumference. And in this case, 70 degrees. We can find out that this angle right over here, using a line property. If there's a line, so I'll draw it. So if there's a line like that, we know that the angle of the line, so we know that the angle of the line is equal to 180 degrees. So that's why we can say that this angle ABD, this kind of line, is equal to the 180 degrees is equal to the ABC, angle ABC, plus the angle CBD. So CBD. Well, we know the measure of the angle ABC, which is 70 degrees. So we can replace, instead of ABC, we can replace it into 70 degrees. So 180 degrees should be equal to 70 degrees plus the angle CBD. So I wrote it down. So CBD. And we can subtract 70 degrees to the both sides in order to isolate this CBD in the right side. And we will get in the right side the 70 degrees we're going to cancel out. And so angle CBD should be equal to 180 degrees minus 70 degrees. We're going to be 110 degrees. So we can see that this angle right over here, it is, so this angle, it is 110 degrees. And if you look at this triangle carefully, this is a isosceles triangle. The reason is because it is 110 degrees, and these two lines are the radius of the circle. So whatever the line it is, the angle we're gonna be same, and the lines we're gonna be same, the length of the line. So we can see that this the line BD is equal to line BC because they're both radius of the circle. So we can see that these angles are same, since we knew that this triangle is this isosceles triangle. So that means 180 degrees for total, which is a total angles addition of the triangle, will gonna be equal to the angle CBD, which is 110 degrees, plus the CD angle, which we can just let it into which we can just let it into 2D, because we're just finding the angle D. We don't need C, so we can do it D plus D, which is equal to 2D. We can just let C into D because they're the same value. We can subtract 110 to the both side, and then we get 2D is equal to 70 degrees. But we're not done yet. We need to divide 2 to the both side, and we get D is equal to 35 degrees. In the next video, I'm going to talk about the but it is third example of the finding the inscribed angles in the circle.